Sometimes, analyzing denial of service attack traffic can help improve a service provider's defenses over time. To do that, we'll implement a sinkhole. Starting on XRV11, I've displayed the class map and policy map to redirect Telnet and FTP traffic into a sinkhole. The class map uses Boolean AND logic and contains two conditions. Specifically, we are looking for TCP traffic, which is IP protocol 6, along with destination ports 20, 21, and 23. This is traffic that we don't want to drop at the edge of the network, but want to discard in a safe area for further analysis. The policy applies two actions. It first sets a DSCP value of CS1 on the packet, then redirects it into a VRF by specifying a route target. I'll discuss both of those more in a moment. Because you've seen this process twice already, I'll focus more on the sync mechanics rather than the Flowspec advertisements. I'll quickly review the enablement of the policy and its origination into BGP using these commands. Recall that you can apply multiple policies per address family within Flowspec. Personally, I prefer that each policy perform exactly one task, although it is possible to have a larger policy with many class maps in it. Here's an example of an equivalent, single policy design if you're interested. We also see a second BGP rule within VPN v4 Flowspec. The rule matches IP protocol 6 along with the destination ports as specified in the class map. Let's quickly examine the contents of that rule. There are two new extended communities. The first one is the redirection route target, which identifies an imported route target on the PE. We'll explore that on CSR7 soon. We also see traffic being remarked to a value of 8, which corresponds to DSCP CS1. This value is typically used for scavenger traffic, and some carriers will use MPLS EXP1 in the core to give this per-hop behavior the lowest priority treatment. After all, we are consuming network bandwidth to transport junk traffic into a sink, and we don't want this to compete with customer traffic. Before heading to CSR7, let's examine CSR8, which is the egress PE towards the sink. I've displayed all of the VRF sync configuration on CSR8, so let's walk through it methodically. First, there is the VRF definition, which exports the same route target identified in the Flowspec policy. Later on, you'll see that CSR7 imports this route target, allowing it to learn VPN v4 routes from CSR8 and Flowspec policies from XRV11. Scrolling down, we see the PE interface towards CSR1, which is our dummy sink and scrubbing center. This is an egress-only interface, as traffic will never enter the network here. I've applied 2 deny any access lists to guarantee it. You certainly don't want your analytics equipment to become launch points for attacks. I've also applied some permit any ACLs on egress so that we can count the packets redirected into the sink. These play an important role in our verification process later. At the bottom, you can see the routing design. I've created a static default route per address family, which points to a dummy next hop on the sink LAN. These default routes are advertised into BGP using network statements within VRF sync. This attracts traffic into the sink. There's one more detail to review, which requires examining the ARP and IPv6 ND tables. Because we are targeting a dummy address, the router will send IPv4 ARP requests or IPv6 neighbor solicitations to learn the MAC address associated to that IP. By setting a dummy MAC address, we ensure that any switches on the sink LAN will treat this traffic as unknown unicast and flood it to all ports. This ensures that all the different analytics equipment will get a copy of every packet. CSR7 also has a sync VRF, so let's head there next. First, I displayed all the VRF sync configuration on CSR7, which imports the same route target exported by CSR8's sync VRF. CSR7 has also learned both the IPv4 and IPv6 default routes via CSR8. These default routes are required to transport traffic towards the sink. BGP Flowspec does not inject new routes, It simply redirects traffic into a different pre-existing VRF, whereby the route lookup is performed against the destination IP. These default routes attract all traffic into the sink once it has been redirected into the sink VRF. For brevity, you can trust me that CSR7 has learned the Flowspec policy and installed it correctly. Let's head to CSR6 to test it out. On CSR6, I attempted to telnet to XRV13, but the connection timed out. This makes sense because the traffic was redirected into the sink, so XRV13 never had a chance to process it. Now, let's return to CSR7 and see how many packets were matched. CSR7 saw 4 packets, presumably TCP SYN messages sent by CSR6. None of these packets were dropped. They were just redirected into the sink VRF and forwarded towards CSR8. We can confirm that by heading to CSR8 next. Although I wouldn't recommend this in production networks for performance reasons, these counter ACLs can help validate your design. We see exactly 4 packets egressing from CSR8 into the sink, exactly matching CSR7's Flowspec count. For extra practice, you can test FTP and the IPv6 variants in your own lab.